does the limit of f of x is equal to x squared plus 3x plus 2 exist as x approaches minus 1? So let's examine that. To the left we have what? Values of x, and to the right we have values of f of x. And what we're examining is what happens to f of x as x gets closer to minus 1. All right, so we start off with x is equal to what? Minus 0.9. And to the right we work out f of x, and we got f of x is equal to 1.1. When x is minus 0.99, we get f of x is equal to 1.01. When x is equal to minus 0.999, we get f of x is equal to 1.01. When x is equal to minus 0.9999, we get f of x is equal to 1.0001. So what we can see from this is that as x approaches what? Minus 1, f of x, which is x squared plus 3x plus 2 over x plus 1, approaches 1. But we already showed earlier that when x is equal to minus 1, f of x is equal to 0 over 0, which is indeterminate. So the limit of f of x does exist, because as x approaches minus 1, f of x approaches 1. And that's the very definition of what limit. It is the value a function approaches at a given value of what? F of x. But so the limit of the function does exist, but the function never reaches that value, because f of minus 1 is indeterminate. F of minus 1 is indeterminate. So you have some function. So therefore, there are functions in which the limit exists, but the function itself never reaches that value. All right, let's have a look at left hand and right hand limit. Left hand limit is the value a function approaches for a given value of x coming, I think that should say coming from the left. So left hand function is the value a function approaches for a given value of x coming from the left. Now right hand function, the symbol, well, later on we'll look at that. Right hand function is the value a function approaches for the same value of x coming from the right. All right, let's have a look at this diagram. This one is what? Piecewise function, where it is the function is defined differently for different values of x. And what we can see is that coming from the left, as x approaches 2, as x approaches 2, f of x also approaches 2. See, when x is 2 coming from the left, when x is 2, f of x is equal to 2 at the very top here. When x is 2, f of x is equal to what? 2, and that is coming from the left. All right, so we can say that the left hand limit, and how do we write that? It is what? The limit of f of x as x approaches 2, that minus in the superscript is saying that it's coming from the left. So that's minus here in the superscript. Superscript minus above the 2 is saying that this is the left hand limit, that you're coming from the left. So as you approach, as x approaches 2 from the left, f of x approaches 2. Now let's see what happens as f of x approaches 2 from the right. So as x approaches 2 from the right, f of x, you can see here, approaches minus 1. F of x approaches minus 1. So the limit as x approaches what? 2 from the right is what? The limit of f of x as x approaches 2 from the right is equal to minus 1. So in this situation, the left hand limit, f of x is a piecewise function. It is defined differently over different domain values. It is defined for x less than or equal to 2, and for x greater than or equal to 2, the function is defined differently. And we could see that the left hand limit and the right hand limit are different. That the function approaches different value of what? Of The function approaches a different value of f of x from the left and from the right. So let's write this back. All right. So the limit of f of x, and this is coming from the what? Coming from the left. The limit of f of x as x approaches 2 from the left is equal to, as x approaches 2 from the left is equal to 2, and the limit of f of x as x approaches 2 from the right is equal to minus 1. So the limits are different. The left hand limit and the right hand limit are different. What else? We indicate left hand limit with a subscript minus sign, and right hand limit with a superscript, not subscript, superscript positive. All right. Limit, existence of a limit. Now the limit of f of x at x is equal to a exists when the left hand limit, the limit of f of x at x is equal to a exists when one, the left hand limit, or exists when one, the left hand limit must exist at x is equal to a, the right hand limit must exist at x is equal to a, and the left hand limit must be equal to the right hand limit at x is equal to a. So a limit exists when for a limit to exist, the left hand limit must exist and the right hand limit must exist. And the left hand limit at x is equal to a must be equal to the right hand limit at x is equal to a. A limit does not exist when the left hand limit and the right hand limit are not equal. And if f of x oscillates infinitely, and a limit does not exist when f of x increases or decreases infinitely. All right. If f of x increases or decreases infinitely, the limit does not exist. All right. Limit law. Suppose the limit of f of x as x approaches b and the limit of g of x as x approaches b exists. So these limits were established that these limits exist. Number one, or law number one, the limit of c as x approaches b is equal to c. All right, so c is a constant. So for example, the limit of 5 as x approaches b is simply what? 5. And essentially it's because there's no x there. Your function is just a constant. So x does not influence the value of your function. The value of x will not change. The value of a function will not change with a change in value of x. So the limit as x approaches b for a constant is the constant. Law number two, the limit of x as x approaches b is b. So for example, the limit of x as x approaches 2 is 2. All right. The limit of x to the n as x approaches b is b to the n. So the limit of x squared as x approaches 3 is 3 squared, which is equal to 9. So the limit of x squared as x approaches 3 is 9. Law number 4. The limit of f of x plus g of x is equal to the limit of f of x plus the limit of g of x as x approaches b. So for example, the limit of x squared plus x minus 3 as x approaches b is equal to the limit of x squared as x approaches b plus the limit of x as x approaches b minus the limit of x of 3 as x approaches b. Alright, and essentially this would be equal to b squared plus b minus 3. Alright, so remember earlier, the limit of 3 as x approaches b is still 3. Alright, the x value does not influence that value. The limit of c times f of x is equal to c times the limit of f of x. So the limit as x approaches b of as x approaches b of 4x squared would be 4 times the limit as x approaches b of what? X squared, which is equal to 4 times b squared. Alright, so we're looking at the limit laws, and so far we've gone through 5. Alright, limit law number 6. The limit as x approaches b of f of x g of x is equal to the limit as x approaches b of f of x multiplied by the limit as x approaches b of g of x. So the limit as x approaches b of x plus 2 times 2x plus 3 squared would be the limit as x approaches b of x plus 2 multiplied by the limit as x approaches b of 2x plus 3 squared. Alright, number 7. The limit as x approaches b of f of x is equal to the limit as x approaches b of f of x divided by the limit as x approaches f of x as x approaches x of g of x. So, to say that again, the limit as x approaches b of f of x divided by g of x is equal to the limit as x approaches b of f of x divided by the limit as x approaches b of g of x. Alright, so down by the bottom here, the limit as x approaches b of 3x squared plus 2 is equal to the limit as x approaches b of 3x squared plus 2 divided by the limit as x approaches b of x cubed plus 1. Rule number 8 and 9. The limit as x approaches b of f of x raised to the power n is equal to the limit as x approaches b of f of x all raised to the power n. So the limit as x approaches b of 4x plus 3 to the power 5 is equal to the limit as x approaches b of 4x plus 3, and this is all raised to the power of 5. All right, and 9, the limit of, as x approaches b, of the nth root of f of x is equal to the nth root of the limit as x approaches b of f of x. All right, let's look at methods of evaluating limits. All right, essentially the methods of evaluating limits are substitution, factorizing, and conjugate. The methods of evaluating limits are um, direct substitution, factorizing, and conjugate. All right, and we'll look at those in the next video.